Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is SVN3E, grade 11 workplace science, and I am Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM or on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available from your teacher and also your DEC. Our classes are scheduled Monday through Thursday from 3 till 4 in the afternoon. And we are in our 5th week of our 9-week course. At this point, we are at the halfway mark, so you definitely should be submitting some work for grading so that you can get your credit. The key questions are at the end of each of your IL lessons in the packet that you'll receive from Wahsa. So you need to do all the questions that are listed. They are not all the questions in the workbook, so don't do all the ones in the workbook. Make sure you're checking in the IL list, just because you don't need to do more questions than you're required. You're welcome to do them, but I won't mark them. So some of them are check your understanding questions in the chapter, some of them are activities, some of them are review questions. So make sure you're looking at the list to know what the questions are. And you want to show all of your work, give complete sentences so that I really understand what it is that you understand and that you're actually answering the question, opposed to just talking with the topic or randomly writing down words. Make sure you're actually answering the question so that I can understand what you understand. You are welcome to do this by hand or electronically. If you want to write in the workbook, you can. There's very small spaces, but if that's what works for you, go for it. If you want to type it up, Google Docs and Word files are the ones that are easiest for me to open. Everyone has access to Google Docs through your NNEC email account. If you want help to access that, let me know and I can walk you through it. If you want to use a different program, because that's what you're most comfortable with, I'm sure that's fine. Just check with me so that we can make sure that I can actually open your files so that I can see all of your work. There are 3 methods for submitting your work. If you do it out by hand, you need to scan it, and either way you can send it electronically. If you're scanning it, you can use a smartphone with either the iPhone Notes app or the Android Google Drive app. Both have scan functions, and that makes the file a little bit smaller and easier to send. You can just send pictures if that's what is easiest for you. Then send it to me through email at studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger at bslatewahsa. The second method is drop your work off in Sioux Lookout. We have an outdoor mailbox at our 74 Front Street location. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. And then the third method is to hand your work into your DEC. Your DEC can either send your work through the Express, or they can fax it to 807-737-1732, or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and YouTube channel are under the name bslatewahsa. All of our classes are recorded, and then I upload them to the YouTube channel so that you can access them if you'd like to. It's all under a playlist called SVN3E. There's also a supplementary video list under SVN3E that has all of our videos that we watched in class there so that you can find them from the original source and actually go into more information if you want to. Science is really visual, so I strongly encourage you to access the videos, either joining me live through the Zoom link or watching the replays on YouTube. If you can't do either of those, let me know and I can send you a copy of the videos so you still get the full experience. If you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. My Facebook is bslatewahsa. My phone number is 807-737-1488, extension 2209. You can also call us toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 till 4. So I'll get back to you within those hours as soon as I can. I think it's important to position myself as your educator before we dive into our subject matter. So as your teacher, I have white settler ancestry, I have white privilege, and that shapes how I teach, how I learn, how I understand the world. And that is important to acknowledge, as it contributes to oppression and problematic realities. So I acknowledge that, and I'm working to address it and confront it, but I don't have everything figured out, definitely. I do live in Northwestern Ontario on the traditional territories of the Anishinaabe people, and I'm working towards understanding things from this cultural perspective as much as I can as an outsider and as a white person. I definitely will not ever understand it all. It's not appropriate nor possible for me to do such a thing, but I'm working towards understanding it in order to honor the knowledge keepers in my area. This is my first time teaching this course, so I have lots to learn and to unlearn. It is a process, it's a lifelong process, but I'm doing my best as I go. If there's anything you think that I should be doing differently and you want to reach out, feel free to. I definitely am open to feedback. Also, our textbook is Eurocentric. It is positions white experience as the experience. It doesn't really talk about other folks' experiences. A lot of the scientists referred to are European or white, and a lot of the communities that it talks about are white communities in Canada. So that is problematic because it is ignoring Indigenous, Inuit, and Métis knowledges and experiences and just their reality completely. So that is a problem. I try to integrate and address that as much as I can into our course, but again, I'm very likely to be missing some things or not having it all figured out. So if you have any suggestions, let me know and I will do my best to improve. All right, we're starting a new unit today, unit number 4, which is using energy in our lives. So just sort of position it. Imagine an area as big as 50 football fields covered in solar panels. Over the course of 20 years, this sun field has enough energy to generate so the panels are making sure that almost 152,000 tons of CO2, carbon dioxide, are not pumped into the atmosphere by coal power plants because people are using energy from those solar panels. This is the equivalent of removing 33,000 cars from the road. So that's a lot of energy that is already just existing. It's just there, and where people could harness it just by setting up solar panels. So in this chapter, we're learning about renewable as well as non-renewable energy sources and the costs and benefits of each. So today's lesson, first, we're just going to start at lesson number 13, understanding non-renewable and renewable energy sources. That's how we'll start this unit, and then we'll move on about how we can, the benefits and the costs. So our learning goals are that at the end of today, you'll be able to describe several non-renewable and renewable energy sources. You know that you've met that learning goal because you can explain why coal, crude oil, natural gas, and nuclear power are non-renewable energy sources. And you can explain how hydroelectric, solar wind, tidal, geothermal, biomass, and hydrogen fuel are all create renewable energy. So we rely on non-renewable energy sources to meet most of our energy needs in our homes, businesses, and schools. But non-renewable energy sources cannot be made or renewed. We're starting to use more and more renewable energy sources because one day we will use up all the non-renewable sources, and also they harm the environment. So we're working on shifting our approach so that we aren't harming the environment and that we can sustain the sources of energy that we need. So first, let's understand what non-renewable energy sources are. The first one we're going to look at is coal. So coal is the most plentiful fossil fuel on Earth. It's removed from the ground using either surface mining or underground mining. Surface mining is used when coal is buried less than 70 meters underground. The topsoil and layers of rock are removed to expose the large beds of coal. Underground mining removes coal buried deep underground. So here is an image that shows underground mining and surface mining. So the original land surface is, you can see in this diagram, so this was originally a hill, and you can see this dotted line here shows the original land service. So on this right side, there's various different surface mining methods. We don't need to understand them all, but you can see that this coal, which are these black lines, are very close to the surface at these edges. And so the surface mining method is cutting away part of the hill and then tapping into those coal beds. On the other side, on the left side, we can see that the underground mining methods are digging deep into those coal beds, and it's a lot farther underground, and you end up really deep underground. So either you could be going down in the mine elevator and then in, or other methods where you're just digging in deep into the hills. Here is an image of surface mining in real life. So you can see how it's got those shelves as the coal is being tapped into at multiple levels as going down. And then here is a picture of underground mining where you can see there, you can't see any sky, you're completely underground, the people are underground, the tools are underground, they have lighting, headlight lamps and such, and they're drilling into the coal beds there. So coal is approximately 20% of Canada's electricity is fueled by coal. So that's a chunk. Once the coal is separated from rocks, dirt, and other unwanted materials, it is transported to electric utility companies and other industries. Power plants burn the coal to make high-pressured steam. The force of the steam is used to turn the rotating blades of an engine called turbines. The mechanical energy of the spinning blades is then converted into electricity by generators. So here is an image of how this is happening. So the coal comes in to the processing plant. It is burned here in a boiler, in a furnace. Water is pumped in from an outside source in through these pipes in the boiler so that it gets really, really hot in here from the coal being burned. The water turns into steam, and then the steam turns these turbines, which then goes through a generator and a transformer, which generates electricity and then transmits it out to other places. The water condenses in the generator as it cools off after it's spun the turbine, and it can be either sent back into the river or cycled back through to go back through the boiler and be steam again. Here is an image of a factory of converting coal into electricity in Canada. Great, so that's what you need to know for key questions 104, questions 1 and 2. So hopefully that can, even though it's just the beginning. So now let's look at crude oil and natural gas. So crude oil comes out of the ground as a yellowish black liquid. Natural gas is normally colorless and odorless, and it's gas. They are fossil fuels that are drilled from underground areas called reservoirs or traps, found either on land or offshore deep under the seafloor. So here we can see different types of drilling machines that could be either gas or natural gas or crude oil they could be drilling for. They're both used. These, possibly they're slightly different. I don't know the inner workings of them, but generally these are the types of things that look like that are drilling for crude oil and natural gas. So after they've been removed from the ground, crude oil and natural gas are transported to refineries. A refinery is an industrial plant that heats oil and gas to sort, split, and reassemble the various hydrocarbon molecules so they can be made into different products. So there's a processing that they have to go through. Crude oil can be made into diesel fuel, jet fuel, and gasoline, whereas natural gas is an energy source for electricity, steam heat production, industry, and domestic uses like furnace fuel. All right, so now let's look at nuclear power. So nuclear energy is the energy in the nucleus or the center core of an atom. If you think all the way back to, I think, our very first lesson, we talked about an atom and how the nucleus is in the center of an atom, which is our small particle that everything's made up of, and that there's protons and neutrons inside that nucleus where there's electrons spinning around it. So the energy inside of an atom can be released through nuclear fusion or nuclear fission. So here's a way to understand the difference between fusion and fission. So fission does not occur naturally. It's something that is human-made, that humans have to make happen. It happens by bombarding a nucleus with neutrons, which targets a chain reaction. So what happens with fission is that you hit, nucleus is hit with neutrons, and then that breaks them apart and starts a chain reaction as then more neutrons hit other nucleus and break those ones apart. It occurs in a nuclear power plant if it's controlled, and in nuclear bombs if it's uncontrolled. Uranium-235 and plutonium-239 are the only fissionable elements. So there's only things that we can split the atom apart and create this energy. Fusion does occur naturally on the sun and stars. In the sun, it uses hydrogen to form helium. What is happening with fusion is that it's the opposite. You're getting two nucleus that are coming together and fusing or sticking together to create something new. 15 million degrees Celsius is what is needed for it to occur. So that's really hot. It's not a practical source of energy because the amount of energy needed to achieve a high temperature is too much. So though it produces a lot and doesn't have very much waste, it's really, really hard to make happen because 15 million degrees Celsius is extremely high. Both of them produce a large amount of energy and both of them produce waste. So neither one is perfect overall. So nuclear power plants primarily use uranium-235 as fuel to make energy through fission. This is because the atoms in U-235 are easy to split apart. Uranium is a common metal that is found in most rocks. However, it is non-renewable, and uranium-235 is quite rare. It makes up about only 0.7% of the naturally occurring uranium on Earth. So it's not a perfect system. All right, we're going to watch a video about how a nuclear power plant works with the splitting of the atoms. Hopefully, if it's going to work for me. So inconsistent. All right, let's go another way.
Ontario Power Generation's nuclear stations are, in essence, factories that convert the energy of the atom into a full electricity. These nuclear stations use natural gas. Which are then blended together to form
So it says how it is free of smog and greenhouse gas emissions. That may be true, yes, but it does create a different kind of waste that we don't have a really great way to deal with. So nuclear waste is another concern. In Northwestern Ontario, they're currently thinking of creating a nuclear waste dump, and there's lots of concerns about that because yes, nuclear waste needs to be put somewhere if we're going to use it, but why are we putting it in communities often close to First Nation communities or rural, remote communities where there's large populations of First Nations people? And why are we putting it into their community that they have to deal with it and they get the repercussions because there are health effects, and that is concerning. So yes, there are benefits to nuclear energy, but it's not a perfect system and it's not waste free. So that's just something to remember. Also, this video showed us how nuclear energy is what heats the water. But again, coal is another one that this is a very similar system in terms of that it's coal that creates the steam. And then also later when we look at renewable sources of energy, again, many of the things are creating that turbine movement that creates the electricity. All right, so now you can do questions 1 and 2 on page 105, the check your understanding questions there. Okay, so let's look at renewable sources of energy. So hydroelectric power, just a quick reminder of what renewable sources of energy are. Renewable sources of energy are things that can either be regenerated or are constantly generated. So something that we don't actually use up, we're just transferring the energy from movement or something into electrical energy so that we can make electricity, but we won't run out of it, or it will be able to repopulate if it is something that we do kind of consume. Okay, hydroelectricity. So hydroelectricity is electricity that is generated from falling or flowing water. Hydroelectric power plants or hydropower plants use turbines like coal, natural gas, or nuclear power plants, but they use the force of moving water to turn the turbines that drive generators to produce electricity. So the water doesn't get used up, it just is moving the turbines. The best places to build these plants are along fast-moving rivers or streams, in the mountains areas, or in areas with consistent rainfall. So places that either the water is moving because it has a strong current, or it's falling because it is falling. Canada's geography is well suited for hydropower, and it's the source of most of the electricity used by Canadians. So often we talk about hydro, that you're paying your hydro bill. And so what that means is we're talking about hydroelectricity. We're paying our electricity bill, and it is coming from a hydro source. Here is an image of one dam in Canada, or one barrage. So you can see the water here is falling, and that is good. There's mechanisms that are capturing the power that's happening when this water falls, the energy that it generates. And then here is another one where you can see the water is moving, and there's a whole bunch of intricate workings within these buildings that are creating energy. All right, so now let's talk about solar power. Solar power is power that's generated by harnessing the energy of the sun's rays. It can be used to heat houses and water and also generate electricity. Solar power is generated using several different methods. There's photovoltaic, active solar, passive solar, and concentrating solar. So we're going to look at how those are different. So first, photovoltaic cells. So photo means light, and voltaic is energy. So we're talking electricity. So we're talking about light electricity. So PV cells are grouped together in panels, and they are made out of semiconductive materials such as silicon or glass. When the light strikes the cells, an electric current is produced. Then it's trapped and transferred to harness it into electricity. So here you can see inside of a photovoltaic cell. So you can see the energy comes into the cell, it's captured by the glass, goes through the glass, and is conducted through these layers. And then it goes through these various cells and then are continuing to the process, and then it turns into electricity. Here is an image of it in real life. Very possibly you've seen fields full of these panels that are facing the sun, that are capturing the light. So then we have active solar technology. So this uses collectors such as mirrors and metal plates to capture solar energy to heat air or water. So active solar energy is often used for space heating or water heating. So here is active solar tech. So it's on, this is a real life example, it's on a house. So these are the panels on top of the house. And how it works is that the sunlight comes into the panels, the panel captures it and transfers it into a water tank, so that boils the water, and then that's how you have hot water. And then it gets pumped back out and through the system again in terms of heating that water. Or it could be air, and a furnace could be the same way, is that it pulls that in and heats the air or water that creates heat for either just heat or for heating your water in your home. Then we also have passive solar technology. So this uses basic building materials like windows and insulation to control the amount of solar energy that is absorbed or lost in a building. So here you can see in this diagram, so this is a home that has passive solar tech. So it doesn't have any panels on it. It's not capturing the light, but it's built such that it maximizes the benefits of the sun. So for example, when it is the summer and the sun is higher wherever you live, then it hits off your roof. Your roof is built to such degree that the sun doesn't come into your house. Yet in the winter, when you have a lower sun angle, then it hits in the windows and it heats in your house because it comes in at that angle. Often it involves trees or hills to help block the sun, depending on where it is positioned within the house. The windows are facing the equator because that's where it's going to be the warmest. That's where the sun comes in, which in Canada, I would just say the winds face the south. But if you are in the southern hemisphere, then the windows are face the north because they're facing where the equator is. That's where the warmest part is going to be. The walls are insulated and the roof is insulated because of that. Captures the warm air and keeps it in, or it keeps the hot air out in the summer. There's no windows on the non-equator facing window, so that it captures and keeps in all of that heat, or doesn't have any heat entering in the summer. So here is a picture of this type of house in real life. So you can see, we can assume that the equator is on the right side, that would be, if we're in the northern hemisphere, that would be south, because the windows are all facing that direction. And there is a hill, the house is built sort of into a hill on the back, so that there's no light coming in on that side, and it's insulated because through the ground. So we can't see all of these things, but that just sort of gives us an idea of how that's working. And that's passive solar tech. Now we have concentrating as the final solar power. So mirrors are arranged in towers troughs, or dishes to concentrate solar energy to drive generators or engines to generate electricity. So there are different ways that it can be concentrating. So how it captures and transmits it into the transmitter, how it can be received. It can be received in a couple of different ways. It often has curved like mirrors or reflectors. They can be bounced off many and then set into like a tower that is your transmitter, or sometimes they can be flat and bouncing into, again, the transmitter. In this real life example, you can see there's two kinds, right? There might be more that I can't see, but from the outside, you can see that it's with these curved mirrors are reflecting and then bouncing into these towers. And then on the other side, it looks like there are the flat ones set up to, again, reflect into this one, depending on where it is and how the sun is going to move. That's solar power. So the next one is wind power. There's lots of renewable sources that we're going through. So wind power uses the kinetic energy or the energy of motion in moving air. It is mainly used for generating electricity or as a mechanical power to grind grain or pump water. Turbines are used to capture the power of the wind. Large turbines are often grouped together in wind farms that provide power to an electrical grid that services homes and businesses. Wind turbines blades, which spin a shaft that is connected to an electric generator that makes electricity. They come in different sizes, but there's two types that they fall within. So the first type is horizontal axis. So horizontal axis turbine looks like a classic windmill that can stand up to 20 stories, which is about 217 feet tall, with 3 blades that can measure longer than a football field. So these are huge. They are the most common type of turbine used today. And this is what they look like. So it's very possible that you've seen some. There are some in Northwestern Ontario. I can't think of where they are right now off the top of my head. But driving along the Highway 17, you can see some if you're traveling to Southern Ontario from Northern Ontario. So these are the blades that spin, they catch the wind and they spin, and that motion generates electricity through that mechanical movement within here. And then there's a generator inside here, and then it's transmitted to lines and cables and sends out to a processing place. And so this would be a wind farm because you can see that there are multiple windmills. And again, these are huge, right? So it's really hard to have perspective, but they are ginormous. So vertical axis, I hadn't seen as much. I hadn't seen ever. So these turbines have 2 blades that go from top to bottom. So they look like large egg beaters. So here is what the vertical axis is. So this is your vertical axis, and these rotate around and around and around when they get caught in the wind. So, and then the generator is down here. So that movement, again, that spinning around movement generates electricity here inside of your gearbox, and then is transferred away. This is another way that it can look, where it has 3 instead of 2 blades, but still the same idea. Your vertical axis, you're moving in that direction where it's going around and around and around like that. So for wind power, both types of turbines can be found on land or water. The pictures I showed so far have been land examples, but here you can see what wind farms look like on the ocean, where they can capture wind really, really well. All right, now we have tidal power. So tidal power, so first understanding what a tide is. A tide is the alternate rising and falling of the ocean on a shore or coastline caused by the gravitational pull of the moon and sun and the rotation of the earth. So this is something that happens in large bodies of water, opposed to small lakes or rivers. And the water is pulled out and then pushed back in, pulled out and pushed back in twice a day. And So tidal power is harnessing that energy. So again, it can be used to generate electricity. You probably know it's a theme. That's what most of our power does, is it generates electricity. A common form of tidal power involves building a large dam called a barrage across a river or an outcropping of land. And the barge funnels water into a generating plant and through a large turbine as it flows in and out with the tide. So instead of it falling or having a current, like in hydropower, the movement of the water going back and forth is what moves the turbines and generates the electricity. So instead of barges, tidal turbines can also be used to generate electricity. So tidal turbines take advantage of the natural tide flows. They can be anchored to the ocean floor or floated offshore. And here are some pictures of the two different types of tidal power plants. So this one is the barrage, where you can see that it's like blocking and the water is flowing through it. And then this one is the turbine underneath the water. Looks very similar to wind turbines, but they're under the water and they're catching that movement of the water instead of movement of the wind. So the Annapolis tidal power plant in Nova Scotia is one of 3 in the world, but it closed in 2019 due to fish mortality. It's killing a lot of fish and getting caught up in the gears and in the equipment. And so then there was consistent equipment failure. So it just wasn't making sense. But here is a picture of it that you can see in Nova Scotia. So now there's only 2 other in the world as far as I know. I don't know if they're still open. I didn't do that research. And I don't know if there's any other ones in the works. So it is something that potentially could be a good source of renewable energy, but we haven't quite figured it out yet in order to make it happen more consistently. All right, now we're going to talk about geothermal power. So geothermal energy is heat that is generated within the Earth's core. So temperatures hotter than the sun's surface are produced deep inside Earth because of the slow decay of radioactive particles. So inside of the Earth, it is incredibly hot. The large area of geothermal energy, called geothermal reservoirs, are found mostly deep underground. So here's a picture you can see where they have these pipes tapping deep underground. So like you can see, so the geothermal reservoir is 4 kilometers straight under the ground. So that's really deep and it has to go through all of these layers of rock before you get to where the heat is. So they inject water into that reservoir that heats it up. And so then it rises and then exchanges, and then that makes the turbine move because we have really hot steam and water that generates and creates power, just like so many of our other ones. So the basis of heat and movement are really how most of our electricity and our energy sources are used. All right, and now biomass energy. We're getting close to running out of them, but there's so many. A biomass is organic plant matter and animal waste. It contains stored energy from the sun. So through photosynthesis, plants convert the sun's energy into chemical energy that they store in their leaves and stems. Then the chemical energy is passed on to the animals and people that eat them. So we've talked about this before in terms of ecosystems and how plants are able to convert energy from the sun and grow, and then so they're the producers, and then the consumers eat those things in terms of getting their own energy, but there's still always energy stored within our cells and within our bodies, both plants and animals. And so when we expel our waste or when we die, there is energy that is caught in those cells still. So some examples of biomass that we use are wood and wood products like bark and sawdust, agricultural crop leftovers. So like when you see a field after they've harvested corn, you can see there's a whole bunch of stalks left. Animal manure and food processing waste, organic portions of municipal solid waste, which to me just seems like a really nice way of saying poop. So there are 3 main ways to convert biomass to energy. The first is biomass can be burned to create heat, same as always, right? So this heat can create steam to drive turbines, generate electricity, or heating buildings. The biomass can be heated, though not burned, to break down into gases, liquids, and solids. And then these can be processed to make fuels such as methane. Or the biomass can be fermented or broken down by microorganisms like yeast and bacteria to create biofuels such as ethanol. So biofuels are mainly used in vehicles, but can be used to power other engines and fuel cells. So that's a way that we can convert biomass into something that we use. Here is a factory that is a biomass factory. So it looks like a factory. Finding pictures, I was like, oh, they all look kind of the same. It's not like you could drive by and I would be like, oh, that is a biomass factory. It just looks like a factory from the outside to me. And then finally, we have hydrogen fuel cells. So this is a relatively new energy source and it hasn't been totally figured out yet. And there's definitely pros and cons as anytime we have a new energy source that we're in the process of figuring out. So it can be thought of as a cross between electrical chemical cell that is used in a flashlight and a generator. So electrochemical cells convert stored chemical energy into electrical energy. However, unlike regular cells and batteries, fuel cells do not wear out over time. Sorry, that says ear out. It should say wear out. Hydrogen and oxygen power fuel cells to make electricity. Their only byproduct is water, which isn't bad in terms of waste and in terms of pollutants. Hydro fuel cells can be used to power electrical vehicles, provide emergency power in remote areas or hospitals, provide portable sources of energy for technology, and power space vehicle electronical systems. So there is some good potential, but it hasn't been completely figured out yet. All right, so those are our renewable and non-renewable energy sources. So now let's see if you can remember them all, because there was a lot. So first, non-renewable energy sources are fossil fuels that we depend on and we are currently depleting. So those were coal, crude oil, natural gas, and nuclear power. So those are things that most of our energy sources are currently generated from these fossil fuels, from these non-renewable energy sources, and we're depleting them rapidly, so fast. And this is contributing to our climate crisis and also is contributing to our energy crisis because we're going to use them all up and we're not thinking about our futures or the separate generations ahead of us in the future and what they're going to do. It's quite detrimental. And then we talked about all of the renewable energy sources that we know about and are using, though not to the extent that we could be using them. So remembering hydroelectric, which is when you have turbines being moved by moving water, either with a current or from falling water. We have solar power, where we have the 4 different types of solar panels. So that are either capturing and converting the energy into electricity with photovoltaic and concentrating panels, or active and passive panels where you are just directly into a home and how you're building that home and how you're utilizing that solar energy. Then we had wind power, where we have the horizontal axis with those big, huge wind turbines that many of us have seen, or the vertical axis ones that look like egg beaters, and those can be both on land or water. The tidal power, which is harnessing the energy of tides, of that moving water within the tides to turn wind turbines again and generate electricity. Remember, solar is creating heat that generates electricity. Wind and tidal are both movement that move the turbines that then can be converted to electricity. Geothermal is the tapping into the geothermal beds deep within the earth that then can heat water and air that then can be used to affect turbines, make turbines move and create electricity. Biomass, which is the organic waste of plants and animals that can be used either as a source of heat to create electricity, or also can be converted, can be changed into different fuels and can be used in different ways. And then hydrogen fuel cells, which is a newer technology using hydrogen to create fuel cells like batteries, not batteries, but that are similar to batteries that can be used to generate electricity. So that is 8 different types of renewable energy sources, and compared to 4 different types of non-renewable energy sources. You'd think that we could get it figured out how to tap into all of these different types of energy sources that are more effective or sustainable compared to the non-renewable sources that there are not as many and are depleting rapidly. We're working on it. All right, so our success criteria are that you can explain why coal, crude oil, natural gas, and nuclear power are non-renewable sources, and that you can explain how hydroelectric, solar, wind, tidal, geothermal, biomass, and hydrogen fuel all create renewable energy. At this point, you can do the key questions on page 109, questions 1 through 7. They're not as many here as they usually are, so take advantage of that, but answer them thoroughly. And if you have any questions, please reach out. As always, we are getting very close to the end of our course. We're halfway through. So if you're struggling with anything, if you're not understanding something or there's disconnects, please let me know and I can support you as best as I can. This is why I am here. So if talking on the phone is the best way for you to communicate, give me a call at 807-737-1488, extension 2209. I do have access to my voicemail now, so you can call and leave me a message and let me know when would be a good time to call you if I miss you. Or you can call us toll free at 1-800-667-3703, still extension 2209. You can email me if that is a more comfortable way of communicating at bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. If Facebook is a better way for you to communicate and you're more comfortable there, I'm also happy to communicate with you there. My Facebook profile name is Wahsa. Remember, our lessons are recorded and uploaded to YouTube at my channel, which is also called Wahsa, and that there are supplementary videos there of all the ones that we watch in class so that you can revisit them if you'd like to and dive down the internet rabbit hole if you want to follow the folks that make the videos that we've been watching. My office hours are Monday through Friday, 9 a.m. to 4 p.m. So that is the best time to get a hold of me, though I do teach the first hour of the day and the last hour of the day, so I'm not available then, but you can leave me a message or send me an email and I'll get back to you with those hours as soon as I can. I hope you are having a lovely day. Thanks so much for joining me. Miigwech.